Hello, dear lovely viewers. You're welcome to another episode of my class. I remain your tutor, Aisha Bandei. So, we have a question to solve today, which is under a topic in chemistry known as electrolysis. So, let's begin. The question says that we should study the diagram below and answer the questions that follow. So this is the diagram we are to study. Please, this diagram is not drawn to scale, okay? But the most important thing is for us to see how the diagram has been sketched, okay? So the first question we've been asked under this is the first question says, what is the setup used for? So this is basically what we call or what is known as the electrochemical cell under electrolysis. So this is an electrochemical cell where we have the anode and also the cathode. And here basically I would just want to explain briefly what we mean by electrolysis. Electrolysis is the chemical decomposition of a compound brought about by a direct current passing through either the solution of the compound or the molten compound. So that is what electrolysis is all about. So answering the first question here, which says, what is this setup used for? At the anode side is it negative, while at the cathode side it is positive. Looking at this setup, the element we have here, as you can see, is copper. Looking at this diagram, as you can see, there are three things we can say is the purpose of this setup. One of the reasons for this setup for this electrochemical cell is for purification of copper. So the first one we can say the setup is for purification of copper. Cu is copper, and also we can say this setup is for electroplating of copper. And another answer could be extraction of copper as well. So extraction of copper. So this any of these three answers is correct for the setup used in this diagram. Is either purification, electroplating, or extraction of copper. Okay, so moving on to the next question, it says mention two compounds that could be used as electrolytes in the cell. So two compounds that can be used as electrolytes in the cell. Before I answer this question, I would love to explain what we mean by the term electrolytes. Electrolyte is a compound which conducts electricity and is decomposed in the process. You know that electrolytes conduct electricity by the movement of ions. Electrolytes also are in form of liquid as molten compound or aqueous compound. So answering this question now, two compounds that can be used as electrolytes in this cell, this electrochemical cell, is can be copper tetraoxosulfate 6, or another compound could also be copper trioxonitrate 5. Okay, copper trioxonitrate 5 or copper tetraoxosulfate 6 is any of this compound can be used as an electrolyte in this cell. Okay, so moving on to the last question, which says that we should calculate the electrochemical equivalent of copper if the cathode gained mass of 3.2 grams when 50 amperes of current was passed for 30 minutes 13 seconds. So in this last question, we are required to solve some mathematical problems. So before we begin, all we need to do first is to bring out the parameters that has been given from the question. It says that we should calculate the electrochemical equivalent of copper. Now, if the cathode has gained a mass, so we have the mass which is equals to 3.2 grams when 50 amperes. When we hear the word the unit ampere, this simply means the current. So here we have the current which is equal to 50 amperes of current was passed for 3 minutes. So this is the time, which is 3 minutes and 13 seconds. Okay, so from here we know that the SI unit for time is in seconds, so we convert the whole of 3 minutes 13 seconds to seconds. So we know that 3 minutes to convert to seconds is going to be 3 times 60. Then we have the plus the 13. So this is equals to 3 times 60 give us 180. So we have 180 plus 13, and this gives us a value of 193. So we are going to use the value of 193 seconds to solve this problem. Okay. So moving on, there's a relation we have to use to solve this as a formula. There's a formula which says under electrolysis, the formula is M is equals to ZIT, where M stands for the mass, the Z stands for the electrochemical equivalent, I is the current, YT is the time. So as you can see, we have the value for the mass, the current, and the time, and we have to look for the value of Z, which is the electrochemical equivalent. So all we need to do from here simply is to make the Z the subject of formula, and this becomes Z is equals to M over IT. So from this point, all we need to do is to substitute in the values that has been given or that we have already and get the final answer. So here we have M has 3.2 all over I, which is 50, times the time now, which is 193. Okay, so when we punch our calculator, by saying 3.2 divided by 50 times 193. But at this point, you have to be very careful with your calculator. If you're not punching it well, it's to give you the wrong value. So at first, I advise my students to take the denominator here, multiply 50 times 193, whatever value you get, then you then divide 3.2 by the value gotten at the denominator, and that gives you your final answer. And when we do this, this gives us a value of 3.2 times 10 to the power of minus 10 gram per column. Okay, so this is the SI unit for electrochemical equivalents. Okay, thank you for watching. This is all we have today on the electrolysis. If you have any question, kindly drop your question in the comment section. God bless you all, and bye for now.